What's up, folks? This is Mr. Walker coming to you with our new set of notes. We talked about classifying polygons previously. This time, we're going to get into the interior and exterior angles in those polygons. So, let's go through and talk about some polygons real quick. We've seen all of these at some point in time in our, academic career: triangles, quadrilaterals, pentagons, and so forth. But did you know that these polygons can be broken up into smaller ones? The smallest one that we have here is a triangle. So we can take this shape here, this triangle, and we can make triangles out of all of these. For instance, when we take a look at the quadrilateral, if we draw a diagonal line from one vertex to a vertex that's not directly next to it, we end up making two triangles, one and two. If we took a look at our pentagon, if I did the same type of deal as we did with the quadrilateral, this breaks up into three separate ones. Now, just like I said in our previous lesson, the properties that go in with these triangles that we're seeing inside these other polygons still carry over. So let's talk about those properties. If we were looking inside of a triangle has three sides. We can't really go through and make any more than just one diagonal using this. And that lets us know that our sum here for all three of these angles is 180. That's just old properties that we dealt with. But what if we continued on with these other ones? For our quadrilateral, friend, just like we did earlier, I could split this up into two smaller triangles. Now, if I could break this up into two triangles, what do we know about these? Triangles have a sum of 180 degrees. So, if this and this are both triangles, that means they're both separately 180 degrees. So, what would it be if we put them together? If we put it together, 180 and 180 lets us know that this quadrilateral has a sum of all of its angle measures of 360. So basically, as we go through, the amount of triangles that we can make using these diagonal lines we could draw will let us know what the total sum of our angles are. So, for instance, this is our friend the pentagon. Our pentagon can be split up into three smaller triangles. If that's the case, that pentagon has a total sum of 540 when we add all three of those smaller triangles together. 180 plus 180 plus 180 is 540. Now, if I continue on, our hexagon can be split up into four smaller triangles, meaning that that is 720. Our septagon, can be broken up into five, which makes it a total degrees of 900. Our octagon has six of these inside of here, which makes this 1080. Our nonagon, 1260, and our decagon, 1440. So something that you should notice, each of these are different increments of 180. This was 180, 180 times 2, 180 times 3, 180 times 4, 5, 6, 7, and 8. But with all of this in mind, is there a faster way for us to look at this? Let's get into our notes, people! The triangle angle sum theorem. The sum of the measures of our interior angles of a polygon is n minus 2 times 180. So, what is n? N has a lot of different things that we can go through and call it. N is, oops, sorry about that. That's crazy. I told you, the computer likes fighting me when I make these notes work. They don't want me to see greatness like that. So, what does this n equal? N is our number of triangles that we can make of that shape. But n is also one other thing. It is that number of sides. If we take a look back at that previous little graphic organizer we were looking at, if I look at the number of sides here, 4, when I subtract that by 2, that gets me 2 sides left, and 2 times that 180 gives us this 360. So basically, we just take the number of sides, subtract it by 2, and multiply it times 180. When we do that, that's us knowing how many of these shapes can be broken down into triangles, and then just taking the fact that we know that triangles are 180 degrees. So we just, multiply it. So let's look at a couple of examples. First one we got here, we're looking at the total interior angles, those sums for an octagon and a 27gon. So an octagon has 8 sides. So we just do 8 sides minus 2 times 180, which gives us 1080. Now this formula that we have here can work for any amount. So let's go through and deal with the other one. This had 27 sides. So what we do is 27 minus 2 times 180 is equal to 4,500. We don't want to draw this out and actually go through and split this up because 25 really small triangles, if you saw with our previous graphic organizer, once we got down to like decagon, the triangles got really, really small. It's like when you guys get pizza from like a pizza party at elementary school and they split it up so much. So we just take whatever the amount of sides is, minus it by 2, times it by 180, no matter what. All right, let's get into this next one. The sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by its number of sides. This is actually giving us the sum first, and now they want us to work backwards. So what were the two things that happened in our formula? We multiplied by 180, and then we subtracted the number of sides by 2. So let's do the reverse of that. For this first one, we got 50/40. We do the reverse, which is instead of us multiplying by 180, we divide by 180. That tells us that there are 28 triangles in this shape. Now, we take that 28 and then we add 2 to it, which tells us that this shape has 30 sides, which makes this a 30-side-agon, or 30-agon, or 30-gon, 30-agon. There we go. Now, that one had 30 sides. This total sum is less than that, so it's probably going to be, a little less. So let's start off with that same step. We divide that total amount by 180. That gives us 14 individual triangles. We then take that 14 and we add 2 to it to give us 16 sides, which gives this a 16-agon. So you can go through and use this formula backwards or forwards to find any of the things that we want. We can find the number of sides. We can also use what we know about the angles in the shape so we can find each of the individual angles. We'll get into that a bit later. All right, that was the interior angles. Let's talk about our friends on the outside, the exterior angles. Now, the sum of the measures of the exterior angles of a polygon, n-gon, whatever agon, is 360. So no matter what, all your total measures outside will be 360. Now, what if you wanted to find just one of those exteriors? What you would do is you would take how many sides your shape has and divide 360 by it. And that will tell you what the exterior angles for each of these are. Remember, 360 is the total, the full sum of all of the exteriors. So if we want the individual ones for this heptagon, we would just divide 360 by 7, and that would give us 51.4. If we wanted it for this 16gon, we would just go through and divide 360 by 16, which gets us 22.5. Now, the good thing of us dealing with the exterior angle theorem is that it's always going to be equal to 360. So as long as you have your exterior angles, you can set up the math as you need. So in this next example, they give us a little bit of algebra. You already know algebra's not going away anytime soon, so let's get used to them. We got 5 sides here. We got 5 angles. We got 86, 2x, 3x, 3x. And this box next. And what does this box equal? It's a 90-degree angle. So all five of these add up to equal 360. So let's get ahead to solving it. I went through and I added all these guys together. I know that the 3, and the two x's combine to give me an 8x. And that 90 and that 86, when I subtract them from 360, that's how I got 184. And then from there, I just got to divide both sides by 23. So some of the examples that we have, nice and easy. It's nice to grasp it. We just got to take our time and not freak out. Sometimes it gets a little more complicated, but we got ways that we could solve it. So take a second and pause the video. See if you could try to figure these out. There's, four of them on the right side of your paper, and there's a couple there on the bottom of your side of your paper. I want you to take a look at them, try it, and come back. Hello, folks. I hope that you actually went through and paused it and took a look at some of these problems. Some of these are a little bit complicated, so I wouldn't be any worse for wear if you did it. Try them. Some of these are a little complicated, a little weird. So let's talk about this first one. It says two rays bisect two consecutive angles in a regular decagon and intersect in the decagon's interior. They want you to find the measures of the acute angles formed by these intersecting rays. So first off, let's look at a decagon. A decagon has 10 sides. And what they said was we have two rays that came through and bisected two consecutive angles. And they want us to find all the angles that are in this area. So, first, let's think about some information. The decagon, we know, has 10 sides. Next thing they know, they tell us that this is a regular decagon. That means that we have 10 equal sides and 10 equal angles. And they also told us this little word here, bisect. Remember what bisect is. It's not going away anytime soon. Bisect means that they are being cut in half. So, to the side, let's figure out what our total number is. We got 10 minus 2 times 180. 10 minus 2 is 8, and 8 times 180 gives me 1,440. This is our total amount of angles. So what we get when we add all 10 of the angles together is 1440. How do we find each of the individual ones? We take that 1440 and we're going to divide it by 10. That tells me that all 10 of these angles are 144. Now, two of these angles, they said, were being bisected by these rays. Bisect, that's cutting in half. So that means that these two angles here on the edge of our shape, here and here, that is 72 and 72. Now that's two of the angles, but there's a third angle here. And if there's three angles, what type of shape is this? It's a triangle. So all we have to do is just take those two 72s and we're going to subtract it from our friend 180. And that'll let us know that the other angle we got there is 36. Nice and easy. Nah, just kidding. It was a little bit difficult. I understand. But we just used the properties in the vernacular that they gave us to make sure that this works out. All right, next one we got. It says 6 angles of a heptagon are 70, 100, 130, 145, and 155 and 170. What is the measure of our seventh angle? So, first thing we got to do, we got to figure out what our total number of angles is. So we got a heptagon, that is 7 sides. We do our formula, 7 minus 2 times 180. That's going to give us 900. So all we have to do is we add all these angles, x, the thing that we're minding, and all 6 of the ones they gave us is equal to 900. When you subtract all of those angles from 900, that tells us that the final angle there is 130. So we just took our time. We were able to do it. Good job. Now, They give us angles inside of these two shapes here. So we got to first figure out what do all these add up to. This first one has 1, 2, 3, 4, 5 sides. So we start off with our formula: 5 minus 2 times 180. 5 minus 2 times 180 gives me 3, and 3 times 180 is 540. So that was the total over here. Let's get the total for here. 1, 2, 3, 4, 5, 6. So we start off, we got 6 minus 2 times 180, and that's going to give you 600 and not 600, 720. My fault. So we got the total number. We got all the angles there. Let's add them up and let's solve it. First one we got x plus 115, 105, 118, 99 is equal to 540. And when we subtract those from 540, we get 103. Easy peasy lemon squeezy. Now over here on the right, we had 6 angles and they were adding up equal to 720. When I subtract all of those from 720, I would have gotten 226. And then when I divided by however many x's I had, which were 2, that's how I got this 113. All right, home stretch, people. We got 3 more to look at. First one, how many sides does an equiangular polygon have if each interior angle is 162? So they told us what each of the interiors were. Do we know how to get the interiors just off the rip? Probably not. But we do know how to find the total. The total number of interior angles is always n minus 2 times 180. But what is that n here? N is how many sides we have in the shape. So if we divide whatever we got here by n, we could figure out how to get this 162 by solving this. So let's set it up. We got n minus 2 times 180 over n, and that is equal to 162 there. Now, this is a fraction. That's not. So let's make them both a fraction, and let's cross multiply these guys. So 1 times all of this is just what's up there already. And remember, this 180 is outside these parentheses. So that means it's going to be coming in later when we start to simplify. On the other hand, 162 times n, that's just 162n. Then I got 180n from me distributing that in there, and I got 360 from multiplying that by 2 when I distributed it in there. I moved the 180 to the other side. Actually, no, I see what I did. I moved the 162 to the right, and I moved the 360 to the left, so I don't have to deal with any negatives right now. That's how I got the 18 equals 360. When I divide both sides by 18, that tells me that n is 20, which means that the number of sides on this polygon is 20. It's a 20agon. Okay. Next one we got. How many sides does a regular pentagon have if each exterior is 24? Just like we did before, we got a little bit of division and we got coming at us. If each of the exteriors is 24, we just take the total amount, 360, and divide it by 24, which means that our number of sides is 15. Now, this last one here is an algebra problem that you might not have been able to think about the first time, but let's explain it. It says exactly 4 angles in a hexagon are congruent. The other 2 are complementary. What is the measure of one of the 4 congruent angles? Did they tell us how big any of these were? No, but they told us that 4 of these are the same. So 4 of these, do we know what the same is? No, but we can say that they're the same letter, like X. Next, we got a blast from the past. It says the word complementary here. If you don't remember what complementary means, that's when 2 things add to give you 90 degrees. And then finally, we got a hexagon, where a hexagon has a total number of something degrees. So let's go through and figure that out. We got 6 minus 2 which is 4. And 4 times 180 gives us 720. So we know all this. These two, this 4x and the 90, give us 720 at the end. So let's go ahead and solve it. We have 4x plus 90 is equal to 720. I move that 90 to the other side and I divide with that 4 and I get 157.5. Folks, I appreciate you watching and thanks for coming by to learn some math with us. Y'all have a good day. See ya.